This video provides an overview of a breathing regulator test stand, which is automated using Hiatronics Development Suite. This test stand is used to check breathing regulators to ensure that they operate properly before shipping them to end users. You'll notice that the breathing regulator in red as the unit under test. This breathing regulator requires an inlet pressure supplied by pressure regulator A1, which is comprised of high pressure gas. So here's A1, and we're going to be supplying high pressure gas to the inlet side of the breathing regulator. The test stand simulates various breathing rates by producing outlet flow generated by vacuum pump S2. So essentially, the vacuum pump is going to simulate the user breathing in on a breathing regulator or inhaling at various breathing rates. The test stand then checks that the breathing regulator will produce specified outlet pressures as measured by pressure gauge I2, while at various preset inlet pressures and outlet flows. Hiatronics Development Suite classifies this type of componentry into instruments, which are green, actuators, which are blue, switches, which are yellow, and PID closed loop controls as purple. The pressure test stand is comprised of an inlet pressure, which would be represented by this first column. So for our testing, we're going to supply an inlet pressure of 50 and 100 pounds per square inch gauge, or PSIG. The test is also comprised of an outlet flow, and that outlet flow is in liters per minute, and we're going to supply a flow of 5, 25, and 100 liters per minute. And we're going to do it twice. So there's basically a subtest here, and then a second subtest here. The first subtest has 50 PSIG inlet pressure, and the second subtest has 100 PSIG. And again, we're going to repeat this same outlet flow values. And again, the outlet flow is equivalent to a user inhaling on a pressure regulator or breathing in. At these test conditions, the test stand then measures the outlet pressure and makes sure that it is between the specified values. So we have the outlet pressure right here, and for the first subtest, we're going to ensure that under all test conditions that the outlet pressure, which is right here, that outlet pressure is between 1.2 and 1.8 inches of water. And then for the second subtest, that the outlet pressure is between 1.5 and 2 inches of water. A test sequence is then written in Hiatronics Development Suite. And here's a little summary of the test sequence. The first thing we're going to do is show an instruction, enter a username. Next, we're going to have the user enter a serial number for the breathing regulator that's being tested. The next step is to show the user an instruction to install the part. The next step is to turn switch 1 on, or S1 equals true. So here is S1, and we want to turn that on as the first step in order that we have pneumatic communication between the pressure regulator and the breathing regulator, so that the breathing regulator can see whatever pressure is supplied by this pressure regulator. The next step is to tell PID 11 that it must attain 50 psig. So PID 11 right here is going to be controlled by the computer. It's a closed loop control, and it's going to automatically look at instrument 1 and make sure that pressure regulator A1 is correct, such that it attains 50 psig and then 100 psig, and that actually should be 100. So now the breathing regulator has supply pressure applied to its inlet side of 50 and 100 for the second time around. So we'll just say 50 for now. The next step is turning on the vacuum pump. So S2 equals true. So we're going to turn the vacuum pump on. And you'll notice that there's a proportional valve that is between the outlet pressure and the vacuum pump. So what we're going to do is we're going to use PID 3_2 to crack this proportional valve A2 until the flow attains a value of 5, 25, and 100 liters per minute. So we're gonna have the PID 3_2 look at the flow meter I3, and we're going to PID 3_2 is going to automatically adjust the proportional valve A2 until it attains the values 5, 25, and 100. So now we have, in the first instance, we'll have, change the pen color. In the first instance, we're going to have 50 psig, an outlet flow of 5 liters per minute, and we're going to record I2, and that would be the outlet pressure. And we're going to check, in this case, we're going to check that I2 is between 1.2 and 1.8 inches of water. So first we're going to record the value of I2 no matter what it is, if it's outside of specification or if it's within specification. The computer will next check if it's inside specification or if it's within the 1.2 to 1.8 inches of water. Then it's going to determine that the test passed. If it's outside of specification, if it's low or high, the value of I2, then the computer is going to determine that the test failed. And that's pretty much it. So it's going to repeat this test for 50 psig at 5, 25, and 100 liters per minute, and then it's going to loop around for 100 psig. It's going to do the same test again. 100 psig, 5, 25, and 100, And the second test is going to check to ensure that the outlet pressure is between 1.5 and 2. So right here, 1.5 and 2 inches of water. And if it's outside of that, it will fail. And that's pretty much it. Next, we'll talk about actually building an application within Hiatronic Development Suite.